Alright, our objective for this lesson is to find the measures of interior and exterior angles in a triangle, and then apply theorems about interior and exterior angles. This is a vocabulary-rich section, so make sure you're taking good notes, you're recording all of the important vocabulary words, and you know how to identify the particular objects that we talked about. The very first thing we're going to talk about is something you guys have probably known for a while, and that's angles in a triangle. And this special theorem is called the triangle sum theorem. The triangle sum theorem says if you have three angles in a triangle, or any three angles in a triangle, their sum is always 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180. And that's the triangle sum theorem, our first theorem in section 4.2. Now there's a relatively straightforward way to prove this theorem, but there are all sorts of other proofs out there as well. So I'm going to do the formal geometric proof for it. I'll put my statements here and my reasons here, and I'll give you kind of the basic argument for it. I'm using an auxiliary line. So I drew line L, and line L is parallel to AC. So my auxiliary line L is parallel to segment AC. And this auxiliary line is just going to help me with my proof. I needed to add it to formulate the argument for my proof. So given triangle ABC, I need to prove that angle 1 plus angle 2 plus angle 3 equals 180. So I am going to start by noting that here I have angle 5, angle 2, and angle 4, and they form a straight angle. Okay, they're not a linear pair because there's more than one of them, but the three of them added together form a straight angle. So I'm going to start off by saying angle 4, angle 2, and angle 5 form a straight angle. And that is given. We can see that from the diagram. I do not like it when we get those stray marks. So secondly, if they form a straight angle, that means the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is equal to 180 by definition of a straight angle. So then I also notice here, remember I told you that L was drawn so that it was parallel to AC. So if L is parallel to AC, that means angles 1 and angle 4 are congruent by the alternate interior angle theorem. So that also means if we have L and AC, with this line BC as our transversal, that 5 and 3 are congruent. So my next step is going to be to say that angle 1 is congruent to angle 4 and angle 3 is congruent to angle 5. And that is the alternate interior angles theorem. Now hopefully you can see where I'm going to go with this. With some substitution, I will be able to get that 1 plus 2 plus 3 equals 180. But first, I need to say that means the measure of angle 1 equals the measure of angle 4, and the measure of angle 3 equals the measure of angle 5. That's definition of congruent angles. And then if I substitute in this equation here at line 2, if we replace angle 4 with angle 1, and if we replace angle 5 with angle 3, we end up with the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. And that would be by the substitution property. Okay, so here's a visual approach as to how you could do it. First, I formed a triangle, and I named the angles 1, 2, and 3. Excuse the inversion. I was doing it on a camera that would reflect the image. Now all I'm doing is cutting the 3 angles off the edges of my triangle so that I can look at just the angles. And you can see here there's angles 1 and 2, or 1 and 3 and 2. Now on a separate sheet of paper I've drawn a straight line using a straight edge. You can see that. And now what I'm going to do is line up angle 1 with the one of the lines on the straight edge, and I'm going to tape it into place. Getting a piece of tape. So you can see there angle 1 is there. I'm trying to go fast so it's not the neatest. Now I'm going to put another one of the angles in place and tape it. So you can see angle 2 there. And now I'm going to put the third angle in place. Again, this isn't precise because I'm trying to go fast. And tape it. And now you can see angle 1 plus angle 2 plus angle 3 equals 180, forms a straight angle. Okay, so now we can use that theorem to let's see, to solve this particular problem where we're looking for the measures of certain angles. It says, after an accident, the position of cars are measured by law enforcement to investigate the collision. Use the diagram drawn from the information collected to find the indicated angle measure. So the first angle that we're looking for is angle XYZ. So where's angle XYZ? XYZ. So we're looking for this angle right in here. Yep, right in there. So if we know that the sum of the angles add up to 180, we've got 62 plus the measure of angle XYZ plus the measure of angle, plus 40, that's angle Z there, equals 180. So the measure of angle XYZ plus 102 equals 180. Subtract the 102 from both sides and we get the measure of angle XYZ is 78 degrees. Okay, so that's that angle there. Now we've got to find the measure of angle YWZ. So I had to start with YWZ. That's this guy right here. Okay, so I don't have this angle in here, but I know that these two guys are supplementary. So if this is 62, that means this has to be 118 because they have to add up to 180. And so that means I have 118 plus 12 plus the measure of angle YWZ equals 180. So if we add these two together, we get 130 plus the measure of angle YWZ equals 180. Subtract 130 from both sides, and the measure of angle YWZ is 50 degrees. Now next we're going to talk about something called a corollary. A corollary is a theorem whose proof follows directly from another theorem. So you're going to have two corollaries from the triangle sum theorem. But first I wanted to look a little bit more into the word corollary. Here it says a corollary in mathematics is a proposition that is incidentally proven by proving another proposition. And then the root of the word comes from a deduction or a consequence. So as you prove one word as a as you prove one theorem as a consequence, you get another theorem, and we call those theorems corollaries. So here are the two corollaries that stem straight from the triangle sum theorem. Corollary 422 says the acute angles in a right triangle are complementary, and that comes from the fact that this is 90, so these two have to add up to 90 because the sum is 180. And the other corollary, corollary 423, says the measure of each angle in an equal angular triangle are 60. If all angles are congruent and they all add up to 180, then they each have to be 60. So both of these can be proven as a direct impact from the triangle sum theorem. A little bit more about triangles. If you were to take one side of a triangle and extend it, you would get this angle on the exterior of the triangle. So here's the interior of the triangle, and then outside would be the exterior of the triangle. So we would call angle 4 an exterior angle. Okay. Now, because angle 3 is adjacent and forms a linear pair with angle 4, they form a 180 degree angle. But the two angles that are not attached or associated with angle 4 are angles 1 and 2, and those guys are what we call remote interior angles. They're away from, and they're on the interior of the triangle. They're away from the exterior angle. So just some definitions that we have to keep in mind. Because we can look at what's next known as another important theorem in geometry, the exterior angle theorem. And we're going to just come up with a plan for a proof of the exterior angle theorem, which says the measures of the exterior angle of a triangle is equal to the sum of the measures of the two remote interiors. So in other words, angle 4 here is equal to the sum of angle 1 plus 2. So I'm going to use the triangle sum theorem in my proof, and I would say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180, and we know that by the triangle sum theorem. We also know that the measure of angle 3 plus the measure of angle 4 is equal to 180 because 3 and 4 form a linear pair, and by the linear pair theorem, linear pairs are supplementary, so that means they add to 180. So now I need some way to relate 4, 1, and 2. Well, the common thing they both have right here is angle 3. So if I take this guy right here and solve for angle 3, let's see what we get. Or actually, I can just set these two equal to each other because they both equal 180. So I get the measure of angle 3 plus the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. And then if I subtract the measure of angle 3 from both sides, subtraction property, I get the exterior angle, angle 4, is equal to angle 1 plus angle 2, which are your two remote interiors. Okay, so let's do a quick example with the exterior angle theorem. For this guy, our exterior angle is angle BCD, and our two remote interiors are angle A and angle B. So these are the remote interiors, and this is the exterior angle. So we know that 5x minus 60 is equal to 2x plus 3 plus 15. That gives us 5x minus 60 is equal to 2x plus 18. And that gives us 3x is equal to 78. And if we divide both sides by 3, we get x to be, what's that? 3 goes into 7 2 times. You would have 1 left over, 18. 3 goes in 18 6 times. So x is 26. So if they wanted to find a measure of angle B, that's going to be 2 times 26 plus 3, so we get 52 plus 3, so the measure of angle B is 55 degrees. Okay, the last theorem that we are going to take a look at in this section has a name as well. It's an important theorem. It's the third angles theorem. And it just says if two angles in one triangle, here L and M, are congruent to two angles in another triangle, here R and S, then that means the third pair of angles are also congruent. So we can draw the conclusion that angle N is congruent to angle T. Okay, we can use that triangle sum theorem now to solve this particular problem, because in these two triangles that are overlapping here, we know that that G and H are congruent and F and I are congruent. So by the triangle sum theorem, we can conclude that K and J are congruent. So we can say angle K is congruent to angle J, which means their measures are equal. So 4y squared is equal to 6y squared minus 40. Now we've got a quadratic to solve. We would end up with negative 2y squared equals negative 40 which would mean that y squared was equal to negative 20, would be equal to positive 20. And then we could take the square root on both sides to get y is equal to the square root of 20. But that's just equal to square root of 4 times 5, which is 2 square roots of 5. And you can get a decimal approximation for that as well. Now, I didn't do plus or minus because we're dealing with real angles here, and I didn't want the answer to be negative. But I could do plus or minus because as soon as we substitute the number in there and we square it, it's going to be positive anyway.